All right, guys, let's talk about Unit 13, Lesson 1, which is collision theory and factors that affect reaction rates. Kinetics is the study of the rate or speed at which a reaction occurs, and a reaction is the breaking and reforming of bonds to make entirely new compounds and products. Effects of collision. In order for a reaction to occur, reactant particles must collide effectively with the following. They need to have the proper amount of energy, and they need to orient themselves in the proper orientation or angle. All right, let's look at this example. We have H2 plus I2 gives you 2HI. The first example, they don't have the right orientation, so these two won't smack into each other correctly. If we look at the second two, they don't have the right amount of energy, so they're not going to smack into each other correctly. But if we look at the last two, they smack into each other perfectly and create two HI molecules. So what about factors affecting the rate of reaction? There are six factors that affect the rate of reaction by changing the number of effective collisions that take place between the particle. So the more effective the collisions are between the molecules, the more effective the reaction is, and the faster the reaction rate is. So let's look at these six factors. So the first one is type of reactant. So ionic substances react faster. It's easy for ions to break when you dissolve them. So if you take, for example, AgNO3, and that would have a fast reaction rate because it's easy to dissolve that into water and it breaks up into Ag plus and NO3 minus. Covalent substances react really slow. That means it requires more energy or time to break those bonds. So this example, H2 plus I2 yields 2H2I, or 2His. That is going to be a slower reaction rate. Concentration. So if you increase the concentration or the amount of particles you have in solution, that will also increase your reaction rate. So the more particles you have, the better you're going to have for collisions. The more collisions you have, the better the reaction is going to be. So in this example, we have a low concentration, less molecules, so we're going to have fewer collisions. In this example, we have a high concentration, we have more molecules, so these are going to be able to collide more with each other, so we're going to have a faster reaction rate. The next one is temperature. If you increase the temperature, you're going to increase the reaction rate. This will increase the number of collisions, and the reactants have more energy when they're collided. Remember, we talked about this. The more energy you have, the more speed you have. So that means you're going to be colliding with your particles a lot faster. So which has a higher rate of collision? A 5-mile-per-hour fender bender or a 50-mile high-speed crash? A 50-mile high-speed crash is going to have a lot more of a reaction rate. It's going to do more damage. If we increase the pressure, so if you increase the pressure, you're going to increase the rate. This helps with gases only. So you have it due to an increase in pressure, you're going to have more collisions, faster reaction rate. Surface area. Bigger molecules are also going to increase the reaction rate. So you have more exposure to particles that can react, more effective collisions. So when you're looking at your surface area, a bigger surface area or a bigger molecule is going to lead to more collisions, faster reaction rate. And the last one is a catalyst. If you have a catalyst, this is something that will speed up the reaction. It's an additional thing that you put into your reaction vessel and it adds more oomph to your reaction. So it's going to increase the reaction rate, but it's not going to be consumed in the reaction. So it's going to be something that's going to be left at the end. It's going to be one of your reactants and it's going to be a product. So let's look at a quick review. Factors that affect reactions. So ionic solutions have a faster reactions than molecules, the molecular compounds. So we're talking about bonding. So if the temperature increases, the rate's going to increase. The concentration increases, the rate's going to increase. The surface area increases, the rate's going to increase. If the pressure increases, the rate's going to increase. If the pressure decreases, the rate's going to decrease. And catalysts speed up reactions. All right, let's look at a practice. At room temperature, which reaction would be expected to have the fastest reaction rate? Pause the video, unpause when you're ready. Great, well, welcome back. Well, the answer to this practice is A, and that's because it's an ionic compound. So that will have the fastest reaction rate. Let's look at practice 2. Under which conditions would the rate of chemical reaction always decrease? Pause the video, unpause when you're ready. Great, well, welcome back. If the concentration of the reaction decreases and the temperature decreases, that's always going to produce a reaction rate that is small. So your answer here is A. Now let's look at your check your understanding. Given the following reaction, the reaction occurs more slowly when a single piece of zinc is used than when the same mass of powdered zinc is used. Why does this occur? We're going to talk about this first thing tomorrow in class. Have a good night.